So what we are going to do, we will split all AQ in your equation into positive and negative ions. So sodium phosphate will be Na plus and PO4 3 minus. This will be ruthenium nitrate will be like that. So everything we will split them. Okay. After splitting, you can see there are some spectator ions. Spectator ions means ions which are same on both sides. Nothing happened to them after the reaction. It was 6Na before the reaction, after the reaction also 6Na. It was 6 nitrate before the reaction and after the reaction also nitrate. So we don't need them because they are not doing anything. So we will cross them out. Okay, those are called spectator ions, ions which are same on both sides. The remaining thing, what is left over, we will write as a single equation which is called net ionic equation. I know this is very foggy right now. We are going to do a simple example first, not from this. We'll do a simple example to understand it. Once you understand it, we can do all the question. It is not a big deal, okay? Don't worry, you will get there because there is a method to do that very easily. But I'm going to teach you the process right now, okay? On your notebook, write the heading, net ionic equation. Net ionic equation. Okay, I'm going to give you a prompt, a question. Okay, very simple. We need a silver nitrate solution is added to sodium chloride solution. Silver nitrate solution is added to sodium chloride solution. Okay? So this is your question. So what is the first step? We said what is the first step? Complete the equation. We are going to complete the reaction. We are going to write that reaction and complete it. Okay, silver nitrate, the formula is AgNO3 and it says solution and AQ. Then sodium chloride, which is what? NaCl, and which is also what? AQ. No, this is combining. That's simple. Yeah. Okay. Then we are swapping the metal to decide the product. What is the product? First one. Ag will go with what? Cl. AgCl plus Na will go with Na3. Whenever you write the formula, metal should come first. Don't write NO3Na. Okay. This is the first step. Okay, second one, I'm repeating each time, okay? You also do like that first time. So, check the solubility rule. Check the solubility. Okay, so I'm going to repeat that one more time. AgNO3AQ plus NaClAQ giving AgCl. And go to your solubility chart. Okay. Cl is here. If it is AgCl, that will be what? Insoluble. So write S there. And NaNO3. Now you memorized Na is in group 1, so that will be what? Soluble. So write AQ there. So now That is a reaction. You can continue only if there is a solid substance there. There is a solid, so you have to do what now? Balance it. So balance the equation. So I'm going to balance it. Is it already? Oh, why did I put a parenthesis here? You didn't see that? It's just AgNO3. We need a parenthesis here. Okay. Okay, so it's already balanced because AgNO3AQ plus NaClAQ, AgCl solid, NaNO3AQ. Okay, at this step we are balancing. Since this equation is already balanced, we don't need to do any changes. Good? Okay, we know that up to this point. We learned up to this point. Okay, next one. You have to split the compound, ionic compound, into positive and negative ions. That is called ionization or dissociation. Okay. Don't worry about that terminology. We don't need that. But I'm just saying. Okay. Whatever things are aqueous, you have to split them into positive and negative ions. Okay, AgNO3. How will you split that? What is the charge of Ag? We know that Ag is +1 and there is only one Ag. So we're going to write Ag plus and that is AQ. And NO3. NO3 and what is the charge of NO3? -1. If you don't know the charges, you just do the reverse crossing method or use the algebra method. Okay, plus NaCl will split into what? Na plus and Cl minus. Write AQ each and every single time. So since in reactants everything existing ionic state, that's why the double replacement reactions are really fast. They don't need to break the bonds. Bonds are already broken. They are already in ionic state. Just combine with others. Okay. Okay. Now AgCl. It is a solid, so nothing will happen to that. You have to write like this. Don't split a solid because it will not dissociate in solution. That's why it is staying as solid. You just copy that there. And next one is NaNO3, which is aqueous, so you have to split them. Na plus NO3 minus. Both are AQ because they are in solution now. Good? Okay, next step. Identify the spectator ions. Oh, what is that? Same ions on both sides. Same ions on both sides. And cancel them out. You didn't cross them out because they are not doing anything. We don't need them. Cross them out. Okay, I'm going to write it one more time. Ag plus AQ, NO3 minus AQ, Na plus AQ, Cl minus AQ, giving AgCl solid plus Na plus AQ, NO3 minus AQ. Okay, what are the ions which are same on both sides? You have NO3, NO3. So I'm going to cross both NO3 out. What are the other one? Na plus and Na plus. Okay, there will be question asking for spectator ions. So now you got the spectator ions. What are the spectator ions? The ions we crossed out, which are Na plus and what? NO3 minus. Those are the spectator ions. Now we need the net ionic equation. Net ionic equation. Okay, net ionic equation, what is left over there? Bring them down. I will always prefer to write positive first. AgAQ plus Cl minus. Nothing. That is only thing left over in reactant side, and right side which is AgCl solid. This is called net ionic equation. This is called net ionic equation. Okay, how do you feel about it? 1, 2, 3, 4, 5. Already 5. There is 1. There is 3. Okay.
Why do we split them into like the?
We are not splitting them. They are actually as ions. They are existing as ions. So something soluble means whenever we added into water, say for example, okay, if you are adding, water has, you know that there is water HOH, there is bonding, hydrogen bond is there. If you are adding a sodium chloride there is an ionic bond. This bond will break and Na plus will go here and Cl minus will go here. So they will split into ions. If the bond is breaking, that is what we say they are soluble. So bond breaking process is called ionization. We are just writing them down. Actually, they actually happen. Whenever you dissolve something in solution, they will exist as ions. Any other question? Okay, now we have 10 questions here. I will do 2 questions today and remaining 8 questions you have to do that as a homework. You have to actually do it. You don't need to write all 5 steps, okay? You don't need to write. I'm going to show you another example with how to write that in a minimum step, okay? Do all this question. Ready? Yes, go. Question number 1. Question number 1, net ionic equation practice. Question number 1, which is lead nitrate and potassium chloride solutions are mixed. So remember the first step, we are writing the complete equation. I'm going to write lead nitrate. What will be the formula for lead 2 nitrate? PbNO3 twice. Very good. And it is a solution. All double replacement reaction, the given will be a solution. Okay, then what is the second reactant? Potassium chloride, which is KCl, and it is also AQ. Okay, now swap them and complete the reaction. Change the metals. K will go with NO3 formula. K has a charge of +1, NO3 has a charge of -1, which is KNO3. Plus, Pb will go with the Cl and formula, it is Pb2, so write the formula for Pb2 chloride, which is PbCl2. Okay, now we have to check the solubility rule. Potassium, alkali metals are what? Soluble, right? AQ there. And chlorides are some condition, restrictions, okay? When it is linked with Pb, it is considered as what? Considered as what? Insoluble. So I write S. Okay, this is a reaction. Why? Then why it is a reaction? Because There is a solid there. So you are responsible for doing what? Do what? What is the next step? Balance it. Okay, go ahead and balance it. Polyatomic ions first. Nitrate 2. 1 on the right side. Will you balance it? 2 before K. Okay. Then is there everything else balanced now? Okay, we had to add 1 more 2 here. Is it good? Yes. Okay, now what is the next step? All AQ need to split into ions because they are staying as ions. So I'm going to split this. Pb2, you already know that the charge of Pb is plus 2 because it is given to you. Pb2AQ. And how many nitrate ions here? 2. So write 2NO3 minus 1. And AQ. Okay, next one. KCl. 1 mole of KCl has 1 K and 1 Cl, but there are 2 KCl. So how many K ions? 2 K plus ions. And how many Cl ions? 2 Cl minus 1 ions. Okay, we are done with the reactant. Go to the product. Which one is AQ here? KNO3. Split that. How many K there? 2K. And how many NO3? 2 NO3. Okay, next question Nikhil is doing under the camera. Okay, PbCl2. Do we need to split them? No. Will they split in solution? No, because it is a solid, insoluble precipitate, they will stay as like that. No, do not split them. Okay, now we are looking for which ions? Yeah, some of you like that, not doing nothing in class, just being spectator here. Okay? NO3 and NO3, spectator, cancel them out. And what else? Potassium also cancelling out. Okay, you got the spectator ions because question will be asking for spectator ions. So list them out. Spectator ions are, you can write 2. The 2 is not necessary, but it's good to write like that. Then you won't make mistake for multiple choice question. 2K plus and 2NO3 are the spectator ions. And we need what? We need what? What is our aim? We are looking for net ionic equation. So whatever things left over, just bring that down, which is 1 Pb2 plus AQ plus 2 Cl minus AQ forming PbCl2 solid. Okay, now we got the net ionic equation. Okay, now we know we got only 4 lines. We reduce the number of steps. I'm going to show you a shortcut to do it. Next one. Okay, so here there is only space for only 2 lines. I'm going to show you how to do that there. April, ready? Number 3, calcium chloride. Write the formula. CaCl2AQ. Silver acetate, which is Ag. How will you write the formula for acetate? C2 silver acetate. Okay, that is also AQ. I don't think so I can write in that space. Okay, so the product will be what? Calcium acetate Calcium need 2 acetate because it has charge of 2 plus AgCl. Okay, now decide which one is precipitate, which one is aqueous. I'm not saying anything, you have to give me the answer. AgCl is a solid, and then the other one will be AQ. Okay, so now we can directly identify the spectator ions and write the net ionic equation without doing all those steps. Okay, which one is the precipitate here? Okay, I'm just copying that. Okay, my net ionic equation is this. AgCl will form from what? Ag plus AQ plus Cl minus AQ. That's it. You got the net ionic equation. Right.
Wait, but C2H3O2 is only one zone.
Oh, yeah. We have to balance the equation. Okay. 2 AgCl, 2 Ag. Okay. Yeah. So 2 Ag, 2 Cl, 2 AgCl. Okay. Now, look, which is a spectator ion? Dhyan, which is a spectator ion?
I can't really read it.
You didn't write the formula?
No, I'm running it right now. It's calcium.
These are the spectator ions, calcium and what? Acetate. So write that. Spectator ions are, whichever one is this, whichever one is aqueous, you are going to write. You got it. Ca2 plus and C2H3O2 minus. There are 2. These are your spectator ions. Is that easy now? We narrowed down, but to write like this, you have to practice all questions. We already did 3 and do 10 questions. In class, we are doing this 4 and 5. After that, we are doing the presentation from last class. So just go do 4 and 5 now. 4 and 5.